Hey guys, this is Harold L.R. Watkins back with another YouTube video. This is related to my AutoTool Advisor debug build, a proof of concept app for testing recommendation logic in a vehicle diagnostic context. This isn't a finished application. The whole point is to test one specific feature and use debugging tools to validate how it behaves. Um, this is my app. The feature I'm testing is a recommendation engine based on the vehicle symptom you select. Things like an ADAS warning or a battery concern. The system is supposed to return the correct diagnostic workflow. I want to confirm it. It returns the right result, and I want to see what happens when it doesn't. First thing I'm going to do is enter an invalid VIN by entering 123. And I'm going to click on run feature test. And as you can see, this VIN gets rejected, validation failed. VIN must be exactly 17 characters. I'm going to clear this. I'm going to enter a correct VIN. I'm going to click on battery concern. And I'm going to click run feature test. And what we see that first we select the battery concern. We click run feature test button. Validation passed. The expected result created, which is expected recommended battery and charging system checks. Then it's going to run the recommended feature logic completed, return result, recommendation, begin battery low charging system and low voltage fault review, and then test ends. So this functioned correctly. It recognizes the VIN as being correct and the feature. What I'm going to do now, I am going to clear the log. I'm going to select ADAS warning, and I'm going to run the feature again. This time, I'm going to run the ADAS feature with the simulate fault. Let's run this off initially so you can see it work. So we see that the button was pressed, the ADAS warning. The simulate fault was turned off. We see that validation passed. Expected result. Recommend ADAS capable diagnostic workflow, which is correct. And feature logic completed. Return result. Um, the recommendation using ADAS capable scan tool. So this works. This portion is the logic that we are really testing. We know what should be used, and we're making sure that the tool picks the correct outcome. So that works. Then what we're going to do, we're going to turn this the simulation or simulator fault on. I'm going to clear the log so we have no logs. And then I'm going to click on this run feature test and read the logs. So the log says we press the button, the run feature test button, validation pass for recognizing the VIN. Expect the result. We expect the recommended result to be an ADOS capable diagnostic workflow. Then we're going to run the logic, the recommendation feature logic. Feature logic completed, return result, recommendation, perform only a basic code scan. This does not align with what is expected. So we know that is wrong. So basically how this is working in the debug panel, I can trace the exact execution path, validation press, the expected result was generated, the logic ran, and the result was returned. That timestamp trace is what makes debugging useful. You see the sequence, not just the outcome. Also, I can see every in the debug log, I can see every step that led to that wrong answer when the button was pressed, when validation passed, when the logic ran, and what it returned. That's the value of having a debug trace. When something breaks, you're not guessing where it went wrong. And just to wrap up the front end portion in automotive systems, getting a diagnostic um, recommendation wrong can mean misdiagnosed vehicles, wasted shop time, or incorrect repairs. So validating this kind of decision logic early before it's connected to real vehicle data is exactly the right approach. This proof of concept confirms the logic works under normal conditions, shows what a failure looks like, and gives me a debugging trail to trace either outcome. Um, and that's what this portion of the demonstration is really about. So what I'm going to do next is I'm going to focus on the code for a moment. Give me a moment while I set this up. Which is probably more important than anything else. Okay, so the first code I'm gonna zero in on is my logic step. So just let me grab it. I'm gonna copy and paste it so I can zoom in. It should be around line 54 or above 54. So 54 is here, and my logStep is here. All right. I'm just going to explain these certain blocks of code. This is the logStep function, my core debugging tool. Every time it runs, it does two things. First, it calls console.log, which sends a timestamp message to the Expo terminal, the standard developer tool that's used in a real project. Second, it pushes that same message to the visible debug panel on the screen, so you can see it. So you can see it in the video. It's a wrapper around console.log that gives me two outputs at once. And that is this block of code actually goes to, let's grab this um, recommendation, grab this. It actually comes from here all the way down to here. This is the block of code that demonstrates that. My next block of code is on or around, I should say, line 116. I will come down, usually above it. And in this case, I'm going to highlight. Right, easier if I just filter for the correct block. Uh, Here in the fault simulation, when the toggle is on and the symptom is ADOS warning, this block runs first and returns the wrong answer. A basic code scan instead of a ADOS workflow. This is called fault injection. I'm deliberately breaking the logic so I can test and observe the failure below that the correct logic runs when the fault is off. That is this block. So the idea is to clearly show debugging before, during, and after the feature runs. Uh, my next block of code is online. Let's see, 215. And let me just filter this way easier. Okay. This is my next block of code. Here's where the expected and actual results are displayed. The expected results come from the build expected result function. That's my predefined baseline for what the system should return. The actual result comes from running build recommendation. That's what it actually returned. By placing both on screen at the same time, I can visually compare them. When they match, the test pass. When they don't, I use the debug logs to understand why. And with that said, that should conclude my demonstration. Just making sure I covered everything for you guys. So we have on line 54, we have logStep function, two outputs. In line 93, we have build recommendation. In line 116, we have run feature test before, during, and after the logic runs. And that does conclude my demonstration. Thank you for watching.